Welcome to the 10th lecture on Module 3 of Ocean Structures and Materials under the braces of NPTEL IIT Madras. In this lecture, we will discuss some new innovative materials and design methodologies which has been tried for protection of coastal embankments. Let us quickly look at what are the primary reasons and causes for coastal erosion, because it is better to understand these causes first before we think of designing or recommending an alternative material for coastal protection systems. The causes for coastal erosion is to be studied to recommend the appropriate material for construction, because we are aiming at the coastal protection. There are two primary causes which are responsible for coastal erosion. As we see from the slide, we understand that natural causes and anthropogenic causes can be main principal causes for coastal erosion. Let us look one by one in detail. Natural causes can be listed as the following. It can be due to the action of waves, it can occur because of action of wind, it can be also due to new shore current, it can be because of tidal action, it can result from storm, it can also result from unforeseen catastrophic events like tsunamis, it can also be related to the slope deterioration process along the coastline, and it can be also from the vertical movement, what we call the seabed compaction, and finally can be also due to instantaneous sea level rise because of geographic changes. If you look at alternatively the anthropogenic causes which are responsible for coastal erosion, they can be listed as follows as seen in the slide. Essentially and primarily, the first reason for coastal erosion predominantly seen in the practical problems is dredging at the tidal entrance. It can also be due to the construction of harbour in the near shore area, can result from construction of other protection structures like groins and jetties. It can also result from river water regulatory works which have been planned and constructed near the shore area. It can also come from hardening of shorelines by construction of sea walls and revetments as one of the coastal protection system which we already saw in the first module. It can result from the construction of what we call sediment trapping upland dams. Sometimes if you plan for any beach nourishment ideas, this can also result as one of the important anthropogenic cause for coastal erosion. Can also cause because of destruction of natural buffers like mangrove forest which are generally developed along the coastal lines, can also because extensive mining of sand and water extraction from the coastal areas. So, ladies and gentlemen, there are two primary reasons why we can see coastal erosion take place in a very serious manner. What are the solutions for such coastal erosion problems? The primary solution for coastal erosion problem can be construction of an embankment. Now, we have a point here to say that one can also plan to construct what we call a saline embankment. Now, the necessity is why one is interested to control the spread of salinity from the seabed or from the seaside towards the offland. The primary objectives of construction of saline embankments are the following. It is useful to prevent the tidal ingression into the adjoining paddy fields. There are many locations, ladies and gentlemen, in India where agricultural cultivable lands are located in the near proximity of the coastal sector. For example, state of Odisha have lot of agricultural lands which are located parallel and in the close proximity of the sea water. So, to prevent the tidal ingression from the sea into the adjoining paddy fields, we can construct an embankment which is otherwise called saline embankment. also to establish connectivity for saving people in case of floods and cyclone, which are unforeseen activities which can happen because of natural reasons. Also to prevent coastal erosion and submersion of land into sea during storm surge, high tides and tsunamis. So, there are many objectives of construction of saline embankments which are generally constructed along the length of the coastline to protect essentially the off land from coastal erosion. Ladies and gentlemen, now I will show you series of pictures which are evidently seen and taken from the site where coastal erosion has become one of the major problem in Odisha. You can see here there is a very close proximity of the land getting eroded adjacent to the sea, and people are using some natural and conventional methods of putting sandbags along the coastal line to protect or to prevent soil erosion further because of advancement of sea. If you look at the following photographs which has been taken subsequently at different time period. For example, if you look at 2007, a photograph taken in the same site, the shoreline was about 20 meters away from the embankment. You can see here that is the embankment, and the coastal line or the shoreline is very close, which is progressing towards the land, where you can see here these are all cultivable agricultural lands. So, the shoreline is hardly 20 meters away from the embankment. A successive photograph taken on the same site an year later shows again it is just 10 meters. It means the sea is rapidly advancing towards the land side. A further picture taken on 2011, which is about 4 years from the original problem being noticed, you will see that the coastline has become completely merged with the land and the embankment has become completely ineffective. About 350 to 400 meter long embankment is completely protected only by local mechanism because of sandbags. So, ladies and gentlemen, you can easily see people use rural technologies like putting sandbags along the coast, providing wooden poles as piles along the coast to protect or to prevent sand erosion or the beach erosion because of the sea. On the other hand, you will see that these are all becoming completely ineffective. As you saw in previous photographs, in the period of 4 years, sea started advancing at a very rapid rate at about 50 to 100 meters every year towards the land side. This has resulted in a very severe erosion along the coastline in one of the sites in Odisha. If you look at another photograph very recently taken in about 30/9/2011, the retired embankment built at 60 meter away on the countryside of the old embankment is a new construction. This is the old one and this is a new one. It is a new construction again, thinking that the advancement can be stopped because of this kind of rural earthen construction. Ladies and gentlemen, it is very interesting for us to academically know that this kind of treatment of embankments are not worthy for the specific site, because the erosion in this particular site is very severe, as a result of which the retarded embankment constructed was completely washed away by, even though they are protected by sandbags. Now the question comes, what are those site specific geological characteristics which generally govern this kind of design and construction methodology of embankments to prevent advancement of sea into offshore? The critical geological characteristics of the example site, what you saw in the photograph, govern the design of embankment as well as material selection for construction of embankment. The site has Montmorillonite clay content which varies from about 7 to 21%. What is the specific contribution of this type of clay in erosion? The size of quartz particle available in the site vary from 0.001 millimeter to 0.0006 millimeter, which is almost equal to size of clay particle. It means in the site around even the quartz particle of a larger diameter are not found. It is a fine clay content present along the coastline in the specific site of subject of discussion, resulting which the soil has attained a very high moisture content. The moment the soil has reached a very high moisture content, the pore fluid is highly becoming corrosive because of enrichment of gypsum present in the content. As a result of which the region is enriched with groundwater potential. The retarded embankment soil acts as impervious layer, creating a very high pore pressure in the soil column, and this high pore pressure is quite dangerous for any type of conventional gravity type construction which can be used for protecting this coast as a coastal embankment. And further, the site has another one more characteristic, which is having a very low slope gradient, because the soil stability at this particular site has been a problem because of very low slope gradient maintainable in the site, and further it is a very low lying area which is generally waterlogged even in case of rains, as a result of which there is an extreme water seepage into the seabed, which results in rise of seawater level actually at the specific site. So, you can see here there are very critical geological characteristics which has governed the discussion of subject here for advising or recommending a specific type of coastal embankment for Odisha. Now, let us quickly see what are those critical factors that may govern the design of an embankment under such soil conditions. The foremost, of course, the data which governs the design of a saline embankment is that the wave climate. The wave climate at this site demands essentially a effective energy dissipation mechanism, because as you saw right from 2007 till 2012 there has been a rapid progress of seawater into the coastal, into the land area, and to affect or to stop or to retard this kind of sea advancement, we should have a design of embankment which effectively dissipates wave energy, so that the further soil erosion or the beach erosion is prevented. So, I should have a design which address the problems related to shoreline erosion, in addition to an effective energy dissipation mechanism to control the wave energy progress towards the offland. Further, the excessive pore pressure warrants a flexible system, because if you have a design based gravity type massive system, it will not work in the site because the soil has got a very high pore pressure. So, an excessive pore pressure in the specific site demands a flexible system instead of a conventional rubble bound embankment which is generally constructed all along the coastline for coastal protection. So, I should look for the design which has got an effective energy dissipation mechanism, as well as the design should warrant for excessive pore pressure located in the site. So, it should be a flexible system, at the same time it should dissipate energy effectively. And of course, the material selection based on which the embankment will be constructed should also meet the appropriate Coastal Regulations Act as applicable to any specific site. So, the conventional sandbagging and wooden piling will not help. As you saw in the previous photographs, they were not able to stop the advancement of sea progress into the land. The erosion rate is very high. It has been seen that the erosion rate is approximately about 50 to 100 meters every year. Now, let us look at a question where what is the proposed design for catering to the geological conditions as we just now saw. The proposed design is a geotube embankment. The embankment will be constructed using a geotube, which is an alternative to address such site specific problems. Now, let us see the detailed design, cross section details and construction methodology of the newly innovative proposed embankment for Odisha coast, which is using geotube as one of the primary core material for this embankment. Now, before we understand the cross sectional design of this embankment, let us quickly see what are the principal advantages of using geotube as a construction material or a core material for a coastal embankment. Geotubes has been seen in the literature as very cost effective. They have a very long life, they remain non corrosive in marine environment, which is one of the important criteria of recommending geotube for coastal protection systems. They are highly durable and have a very high tensile strength. They enable a very fast construction. The period of construction of embankments when used with geotube are relatively less in comparison to the conventional rubble mount type embankments. It also, in addition, ladies and gentlemen, dissipates wave energy because of the design. The design uses gabion boxes filled with stones and tied with adjacent gabion boxes as armor units, which is not preventing or which is not protecting the geotube from further erosion. The geotube movement, being flexible in design and nature, dissipates wave energy as a wave approaches the embankment. So, instead of having a rigid conventional gravity type massive rubble mount embankment, a newly proposed flexible geotube core gabion box covered embankment is an alternative suggestion made for this coast in the literature. Ladies and gentlemen, now the figure what you see here shows the detail of the embankment in its cross section. If you carefully watch this figure, you will see that the core consists of about 4 layers of geotubes which are placed in a pyramid order as 4, 3, 2 and 1 in a specific order as you see in this cross section. Now, once the geotubes are being fixed and laid, over this we provide gabion boxes which are mounted and covered with 200 mm size rubble stones, which can offer enough resistance by counterweight to these geotubes to be held in position. If you look at the details of this construction, the armor essentially consists of 2 meter by 1 meter by 1 meter polymer rope gabion box with an aperture size of 150 mm, which is filled with stones of 200 mm, which acts as a counterweight on the top of this core material of geotube, which forms an embankment. The core of the embankment consists of geotube bags of 4.4 meter by 1.6 meter, which are essentially filled with sand. The bedding layer where the geotube layer will be laid is about 150 mm thick sand layer consisting of 20 mm stones. The filter layer of 230 GSM geotextile will be also laid over 500 mm thick sand bed layer to act as a subgrade for the geotube arrangement. The toe mount is also designed to protect the embankment, which consists of 6 meter wide by 3 meter in depth on the sea side and 6 meter wide and 1 meter in depth on the land side, using 2 meter by 1 meter by 1 meter gabion box. The scour protection is also an important component of this embankment design, which is done using the gabion box of size 2 by 1 by 1 meter for a total dimension of 3 meter wide and 3 meter deep. All gabion boxes in the arrangement are kept staggered in position and they are tied using high density polyethylene ropes, what we call HDPE, which is eco and environmental friendly and non degradable. The overall view of the finished saline embankment as proposed an alternative design for the conventional rubble bound embankment is shown in the slide now. The base width of the embankment will be about 20.72 meters, which is having a 6 meter on and 3 meter on the right side on the sea side, essentially for protection. The core material has got sand filter beds which is covered essentially by the gabion boxes, which consists of 200 mm stones being filled, which will act as a counterweight on the top to hold the geotubes in position. The high tide level which is seen in the specific site has been indicated as 4.3 MSL, whereas the top level of the gabion box arrangement of the embankment goes to about 7.4 meters. The top crest width is about 4 meter, while the bottom crest width is about 20.72 meter. You can easily find out a gentle slope of this which is provided for this embankment. Of course, the embankment has a foundation depth of about -3 meter on the sea side as well as on the land side. If you look at interesting component of holding down the gabion boxes in position, you will see that the slope stability of the land side as well as the sea side is being achieved by tying these gabion boxes, as you see here, which are staggered alternatively, by tying these gabion boxes using high density polyethylene ropes, and therefore they are placed in position. Now, as there is no permanent rigidity offered by this kind of arrangement in the whole embankment, we can see that the integral component of the geotube with that of a gabion box maintains high degree of flexibility in heave direction as well as in the direction of wind action or the wave action. So, because of this flexibility imposed or imparted by the combined action of geotube on the gabion boxes as well, this system is able to dissipate energy which is coming from the sea waves to a very high extent, and that dissipation prevents further progress of the sea wave as well as protects the land side, interestingly, because of further erosion. If you look at the construction methodology of the newly proposed saline embankment using geotube core, which is placed over and above the gabion boxes as an integral arrangement, the bed layer of this arrangement consists of 500 mm thick sand which is first prepared, over which the geotextile fabric of 230 GSM is laid over the sand bed to act as a filter. 4 layers of geotubes in the pyramid order of base as 4 followed by 3, 2 and 1 which is on the top are laid subsequently. The gabion boxes are laid over the geotubes and tied with the high density polyethylene ropes in position. The toe mount and the cover protection are also constructed using the gabion boxes for the respective purpose. If you look at the photograph here, this is how a geotube will be looking like before the sand is being filled in. So, geotube is being laid on the ground and geotube is now getting filled with sand. You can see initially it was flat, now it has got bulged out. So, now after the geotube is completed in terms of filling, it is again provided with counterweights of sandbags on the top. This is one of the views after the installation. This is my geotube and these are my HDPE rope with the gabion boxes placed in position. So, now you will see that the geotubes with the gabion box placed on the top will what look like. Now, here instead of gabion boxes filled up with the stones, there are stones which are directly laid and being tied in position. So, instead of this we can also have an alternate arrangement where the gabion box of specific size of 2 meter by 1 meter by 1 meter, which are filled with 200 mm size stones, are laid on the top and they have been held in position by staggering them in arrangement using the HDPE ropes. That is an improved version of the existing type of design which can now be effective, which can also offer a high degree of flexibility for dissipating wave energy on the coastal side. If you look at a conventional design of embankment protection using a rubble mount design, this is what people generally do for a rubble mount embankment, where the core material is essentially an hard rigid core material of 150 kg stones present here, whereas which is covered by an armored layer of about 2.5 to 3 tons of stones in 2 layers. So, this is a rubble mound conventional type of construction which offers very high degree of rigidity, which does not suit for a specific site where there is already a high pore pressure in the soil. This pore pressure is because of the soil erosion and the entrapment of water and the high level of sea rise in the specific site. Now, a fundamental question comes to an engineer's mind is how a technical comparison will look like between the proposed new innovative type of embankment design with that of rubble bound embankment, which is highly conventional. There are many factors which are considered to compare their technical performance. Let us look at the site suitability. As we saw in the previous slides, geotube embankment is suitable to the site because of high pore pressure that demands a flexible system. Obviously, rigid bound system like rubble bound embankment is not applicable to this site. So, it is not suitable for the site under discussion. If you look at the suitability to wave climate, the geotube embankment methodology suitable as the proposed system has inbuilt wave energy dissipation mechanism because of vertical movement of the geotubes under wave action or under the water body. No such vertical dissipation mechanism is available because rubble mound embankments are very rigid in its construction methodology as well as in design. If you look at the risk of soil erosion to the adjacent unprotected area where the embankment is constructed, the geotube embankment methodology reduces and minimizes the risk because it dissipates the wave energy in a more effective manner. Since the rubble mound embankment does not have a provision of dissipation wave energy at all, there is no guarantee that the adjacent unprotected area will not have soil erosion. If you look at the design adaptability, geotube embankment is seen as most suitable for the site due to extensive flexibility offered by the design principles, whereas rubble mound system is highly rigid and does not suit for this specific geo aspects. Of course, look at the cost effectiveness, which is one of the important milestone for deciding any type of new innovative construction methodology for such coastal protection structures. Yes, the cost benefit is there in the long run. However, the initial investment on geotube embankments are relatively higher. Studies show that they are approximately about 70% costlier than that of rubble bound embankments. The initial investment on this kind of embankments is comparatively cheaper. If you look at the eco friendliness, yes, geotube embankments remain non corrosive in the marine environment and therefore eco friendly. Of course, rubble mound embankments remain eco friendly because they are essentially constructed of using stones and earth. If you look at the time of construction or period of construction, which is one of the important factors to select the type of embankment design, geotube embankments are comparatively very fast in relationship to that of rubble mound embankments, which are relatively slower. Further, inspection and maintenance becomes very easy because it is possible to carry out periodic repair and systematic manner in this kind of embankments, whereas in this case it is not possible. No such procedures exist in the literature and they are ever practiced. If you look at the geotechnical investigations and considerations as applied for the specific site of discussion, we can see that the geotech embankment remains suitable for mudsliding soil type as seen in the specific site, whereas under this situation the rubble mound embankments are not at all suitable. Above all, the most important technical factor says that based on numerical studies we have seen that the geotube embankment, the factor of safety shows more than 1.4, whereas rubble mound embankments for the same dimension it shows a factor of safety less than 1.4. So, looking at the important factors based on which two different designs can be compared, we come to a conclusion that geotube embankment has lot of technical advantages compared to that of rubble bound embankment. So, before we go for final recommendations, one would like to know what is the cost benefit analysis one can do to get compared with geotube embankment with that of conventional rubble mound type embankments. So, based on the cost benefit analysis studies conducted of two designs, following critical observations are made. Initial investment of geotube model is about 62% higher in comparison to that of conventional random rubble mound design, there is no doubt on it. However, the technical suitability of the geotube design is far superior for the chosen site location. So, it is site specific design. Therefore, this derives an assured benefit in comparison to that of random rubble mound embankment, because it is highly suitable for a specific site under discussion. Further, if you look at the time of construction or the period of construction taken, the time taken for construction of geotube design is comparatively lesser than that of the rubble mound type due to modern construction methodologies. This should also add to the direct benefit to the society, because we can construct such embankments in a shorter period of time, which can again benefit the society in short period of effectiveness. The geotube design also offers dissipation of wave energy, which is an additional benefit derived because of the flexibility in the design. In the specific site of discussion, we believe that this is essentially important because sea has been progressive into the land at a very faster rate. So, I need to have a mechanism in the embankment design which dissipates the wave energy effectively. Therefore, further erosion is either reduced or completely mitigated. The effective dissipation of wave energy would most likely prevent further erosion adjacent to the proposed embankment. Materials proposed in geotube design are non-corrosive and highly eco-friendly, and they have been found best suitable for the marine environment. This implies a direct long term benefit to the investment in the commercial point of view of the suggested innovative design. Therefore, geotube type embankment is the best suitable for the proposed site due to special geotechnical problems, for example, high pore pressure and slope steepness. Also, the climatic conditions govern the new design, for example, sea level rise which is consequently happening in the site, high tides being seen in the near vicinity, increasing coastal erosion in the recent past of 4 to 5 years are all important natural factors which govern an alternative innovative type of design for this specific site, which dissipates not only the sea energy, wave energy, but also protects saline ingression into the land which is cultivable. Further, importantly, the sensitivity analysis performed on both the designs show that the geotube has an higher factor of safety, which is much more than 1.4 when compared to that of conventional rubble mound design, and therefore, this shows very higher practical applicability of the design. Therefore, ladies and gentlemen, in this lecture we learned a new type of coastal embankment design using modern construction methodology and modern construction material. These designs which are proposed as an example in this specific lecture are site specific. Therefore, instead of going for conventional methodology of coastal protection systems, people are now approaching use of new innovative construction material and construction methodologies for such coastal protection structures. Thank you.